So quick recap, TDD, and TDD and SPS, and I am Erik Summerfield from Phase 2 Technology, who has a new fun brand. I want to thank all the sponsors because they made me a hero this morning because my daughter was like so excited to have all these stickers. She just woke up. That's why you kind of have that crazy look on her face. That's not normal. And then let's get into it. So first thing I want to talk about, what is SPS? It's a site preview system module. It basically lets us, yeah. So it basically lets us pick out different revisions of content of any type of entity and then see what the site would look like if those were published. We'll do a quick demo here. The thing to mention is that it was developed as part of the Content Staging Initiative, which was funded by the Acquia Large-Scale Drupal project, which is actually a kind of interesting funding mechanism. Acquia got a whole bunch of really big companies that use Drupal together, got them to pool their money and build something that wasn't necessarily related to any one of the projects. They're all using it, but it was kind of a nice way to fund building a new module that did something different and new. So it's actually interesting to look into if you want to check that out. So what does I want to go do over here? I was going to give an example. Oh, let's cancel that. So here's a site. We're saying that a client made this site for us because they liked us so much. So here's my boss. Here's the guy I spend most of my time with, and here's me. But we made them mad for some reason, and they said, if you don't finish our website by October, this is what it's going to look like. So we come in here, and they say site as of October, and then we enable it, and all the content changes, right? These are all new revisions. And you'll notice that, so this is just the normal Drupal homepage. This is a view. So they're all changing in the view as well. Over here on the left is the recent content block. You'll notice that they've changed, the titles have all changed, but they don't have these pretty things around them. And I'll get to why that is later on, but it's part of the architecture. Get a better job of actually changing content than finding where the content was changed. So this is basically what it does. It's right now using the ERS module, which is a module that lets you just say when you're going to publish something. It also works with the state machine module and Workbench, and then a few other things. If you go to the SPS site, it shows the kind of stuff it works with. But it's kind of nice to be able to just see the entirety of the site, not just the one article. Of course, if you go to one article, you will see that it's been changed. That's pretty straightforward. So that's what it does, although what it does is not nearly as important for this talk. I just kind of wanted you guys to get a framework for what it looks like. There we go. So what is TDD? So it's test-driven development, and as we were talking about earlier, they've things now called BDD, and I think a lot of times a lot of those concepts all get lumped into TDD. So what I'm talking about is basically the process of writing your test before you write your code. So I have this like double loop that I use to describe it, which is that you write a test, you make sure the test fails, then you write code to make it pass, and then you have fun refactoring. So yeah, lots of people have different things. This is what I'm talking about when I say TDD. And on the SPS module, we didn't do it 100% of the time, but we did do it a lot. And these are sort of the big benefits that we got out of it, is that refactoring was just fantastic. And we did a lot of refactoring, way more refactoring on this module than pretty much any other stuff that I've worked on, until I did another TDD project. So it encourages it to happen, right? Because you're not worried about all the things that you're going to break. The second part is that we had 3 developers working on this pretty much full time, and we were all working on different parts of it, and it let us communicate what we expected from each other pretty easily. We could see each other's tests. We could actually use them to figure out what the code was going to do. And also, it made it clear when we were breaking other people's code. Another big part about it was I went into another person's code and did a pretty strong rewrite of it without being scared that I was missing something, some nuanced thing that they had done. And not that I wasn't scared of it, because when I did that, which I broke a few times, and then test broke, and I had to go to the person and say, hey, why is this test breaking? This seems stupid. And he's like, well, that's because you missed this nuance, right? So it sort of just helped us collaborate a lot and get to where we wanted to go. And the other part was the fact that we were writing tests made it really clear when we had really bad APIs, because we couldn't write tests for them. That's like, was fantastic, right? It was like, I literally would try to write a test for what I wanted to do, and it would come out as being this big kludge with all these extra injection things happening, and I was like, wait, all right, maybe there's something wrong with what I'm trying to do. And so I fixed that before I actually spent all this time writing that module or that object. So it was quite nice. One other thing that I mentioned is even when we didn't write our test first, which did happen sometimes, we would go make sure that we would write a test later on. And one of the key things if you do that is to break your code to make sure your test fails. So if you write your test and it succeeds because your code's working, you'll find sometimes if you break your code, it will still succeed because there's something wrong with your test. And so then just make sure you make sure the test is going to fail, even if you're writing it on code that's already there. So doing TDD in Drupal, which is very doable. The big first piece is unit test versus web test. So if you go talk about doing TDD and you search for Drupal and TDD on the web, you're going to get all these articles that say how Drupal is horrible at doing TDD because it takes so long to run all your tests. And Drupal has two types of tests that you can do. You can write web test or unit test. And the web tests are horrible because they take so long to do. And they're just not targeting doing test-driven development. That's not their point. They're really more for doing integration tests. But with a web test, it spins up a new site, puts in a whole new database, does an install for every single test. So really, at a minimum, it takes about 8 seconds to do a test. And that's why if you try to run all of the tests in Drupal, it takes like 2 hours. Because that's what all those things are doing. The unit test does not do that. It does not do any of those things. The big drawback, of course, means that you can't do anything with the database, because there is no database to do anything with. So you really have to target your test to code that's more functional. And this is why doing the stuff as object-oriented helped out a lot, too, because we sort of could abstract out the Drupal part of it for doing the testing of our pieces. But if you're doing unit tests, you really can do TDD in Drupal. If you have to do web tests, you're just going to fail, right? You can't type out your test, wait for 8 seconds for it to fail, go write your code, and then you can't iterate at all during that process. Especially someone like me who writes really, really typoed code, which is going to break over and over again. So I need to iterate pretty fast. So let's talk about. Oh, did I miss? Oh, hold on one second. I missed a jump off point here. Was it here? No, it was here. So most of the stuff I'm going to talk about actually is contained in this blog post, 3 Easy Steps to Drupal Unit Testing. Although there's actually 4 steps, so it's kind of a bad name for that. Let's go through those steps. The first step is telling Drupal about your test. So I'm going to show you what we do this in SPS. We kind of cheated. All you have to do is tell Drupal where your files are. We were using the X autoload module, which is kind of a D8 concept that's been ported in for organizing how you put your classes in this file structure, and it gets namespace, and you'll see it as I show you where some of the files are. It's kind of grotesque at first. But also you could do *.test, so that was kind of nice. So all of our tests get loaded. But otherwise, you just list out what your test files are. And so that was an easy step, right? The next one is the base class, and this step actually isn't necessary, but I found it very useful. So what you can do is you write a base class, which you inherit from, in this case, the Drupal unit test. So you are writing a class for every single set of tests, I guess, is what you would call it. And there's a little bit of fudginess you have, because you could just have one of these with a whole bunch of tests, right? So, or you could break them up. We did basically one of these for each class that we were testing. But depending on, there's no real right or wrong way, I don't think, to decide how you're going to break these things up. But the first thing you do here is we have a setup function. So there's things that we wanted to do, which is like load the code for xAutoLoader, SPS, and SPS tests, because those are the things that we're going to use for testing. So you do these Drupal loads because you really can't do a module enable, because module enable would hit the database, which would fail and blow up badly. So we actually have our own module enable function. I forgot exactly what it does with SPS tests, but we had to do something special with that one. And then we had this extra xAutoLoader junk that we had to do to make all of our tests work too. Normally, you won't have to do that if you're not, I think there was something special what we were doing that we had to do that. But it's nice because, and part of why I don't know about it is because I only had to do it one time, right? And then all of our tests had that. So it's kind of how you would use a setup. The other thing you can do is write your own assertions. So let's come down to this one. Most testing frameworks have like an assert throw, which says, hey, this code should throw this error. Drupal's doesn't. It actually has a good reason for it. Is because Drupal works in PHP 5.2. And PHP 5.2 doesn't really have good closures. So you kind of need that to run this, right? So what this does is you pass it in a chunk of code. It executes that code and checks to see if it threw an exception. And if it threw the right one, if it threw with the right message, that kind of stuff. So it was convenient to use this because we needed this on all of our tests. So you can write your own assertions if you have sort of things that you would be doing. It's just a function, right? Pretty straightforward. And the big pieces that you use is this fail and this true, or this pass, which are the really base statements. You can actually use those in your test as well if you wanted to, as opposed to using other asserts like equals and that kind of thing. But that's how you sort of construct a new one.
So just to be clear, that your assert throw function is part of the infrastructure for testing.
It's not a test, right? It's a tool for, we'll show you how you would use this later on. In about 5 seconds, actually, because we're going to go show a test, how I would invoke this test on a chunk of code. So, yeah. And I'm pulling all this code, by the way, just from the Git repo on D.O. So, nothing crazy there. The next thing is actually writing our tests, which are nice and easy. So, for each test, or each test class, right, you have Git info, which just tells you what's the name of it, a nice little description of it, and the group. The group is helpful for when you want to run a group of tests together. You can say, run all the SPS tests, which is what we do. That's why I put them in this group. Then, and I kind of find this a little bit kludgy, but you're writing your test functions by starting them with the word test in all lowercase letters. That's how it distinguishes what a test function is from a test method, I guess, is from any other method. So it's easy enough to understand, even if it is kludgy. But actually, let me pause for a second here. How many people, I was supposed to ask this at the beginning, and then the whole mic thing threw me off. How many people have wrote a unit test in Drupal? How many people have written a unit test in something else? OK, cool. How many people have done TDD in either Drupal or something else? OK, cool. OK, cool. So let's move on then. So here we go with our first test, which is a very nice, simple one, which is part of why I picked it as an example. So I'm, build my new object, and then I have these two little functions that I make, org and replacement, and then I just do some basic asserts, right? So this is an assert equal. So these first two things should be equal. That's all I'm saying, right? So if I pass Drupal the object and I call org on it and pass a 5 in, I should get the same thing if I just call org and pass a 5 in. We're going to talk about actually what the Drupal module does later, so I'll just let that be a little bit of a mystery of why I would do this. But it's a pretty straightforward concept, right? And then you have this nice big thing that says, I always use the should language with this, but this is basically what it gets informed back to you if your test fails or succeeds. So I'm saying this should happen, so it's clear what is going on in this method. The key thing about the language on this is one of the best ways, this is like a good documentation about what your module is going to do. So think about that when you're writing this, right? That somebody should be able to come to your test and go and read that and go, oh, OK, I can use this class to do this. And in fact, when we go and talk about this, I'm actually not going to show you the code for the object. I'm just going to go through the test. And it should completely explain what the object does. Let's see if we have I think all of mine are assert equals, yeah. So maybe this wasn't such a good example. But yeah, so I use assert equals. There are a set of different assert ones. If you go look at the base class, all of them are methods off of that. So you'll notice I'm calling this assert equals. So just like when I added my new one, it was going to be this assert throws. So if you look at the base class for the Drupal unit test, it has all the different asserts that you can do that come built in. And of course, you can build new ones if you want new ones. So that's sort of the anatomy of building these. Does anybody have any questions on that? I mean, it's actually not that hard. Yeah, go ahead. Yes, all this does is, yeah, it just adds one to that parameter. No, I expect I pass 5 to the method org of Drupal, and I expect to get the same thing if I pass 5 to the function org. Yeah. So I'm just saying they should return the same thing. Yeah. Like I said, I'll explain why that is towards the end. But all right, cool. All right, so let's kill that one. All right. So this was step 4 that I didn't have numbered, which is actually running the test. I think about that when I was writing the blog post at first, and I had a cool number 3, so I sort of snuck it in. So running the test is pretty straightforward. There's a PHP script. You can actually do it through the interface. Of course, I don't really like doing that in TDD because it takes longer. So this does pretty fast, just running it from the command line. The first command is to run on a group. The second one is to run on just one class name. So that's the one I actually use when I'm iterating. And you can do verbose, which I'll show in a second here. Just gives you a lot more information. The first one just tells you which number of tests it's seen failed. This other one tells you actually which ones. So let's go do this. And I was supposed to do this beforehand. Sorry.
This is a bash script that
And yeah, it's actually a PHP script that's inside of Drupal. I never used Drush to do this. I imagine that it probably should. It probably runs the script. That's the wrong way. Zoom in. There we go. You think that's big enough? All right. So here was the first one. And we run it, and it tells you what it's going to run, and then it runs through all the tests. So I think we have like 120 or something tests total in the module. And you'll see it runs pretty fast. Ooh, look, we had a nice failure. That's convenient. So I could then look at that particular class and run a verbose one on it, and see it actually tells me, which ones actually failed. So where it is in the test and what's the message for those failing. I think these are actually failing. These are actually real failures that are currently in the module, which is such a bad thing. But I think that it's basically those tests need to be removed because that functionality got removed and they didn't remove the test, which is an easy fix, but something that should have still been fixed, right? Because having tests that break is almost like not having tests because then people start ignoring the results of tests very, very quickly. Yes?
I'm assuming those are line numbers that we're seeing in the middle?
Yes.
Okay.
Those are line numbers to the test.
To the test.
Mm-hmm. I think yes. Yes.
It's not like an exception or a failure where you'll find out where it was.
No, it's just telling you which test is failing.
That still gives you a lot of granularity, finding out why something isn't working.
Yes.
You don't have to go hunting.
Right. You'll know what function you're testing there and why it's failing. So, and usually, if you're doing this right, like I said, and you're fixing your test after you do it, you just did something that broke a test, right? So it's pretty helpful to find it pretty easily. That's another thing, like using the web tests. We do have a few web tests because we do have some kind of integration kind of testing, but you tend not to run them right when you write new code. So they're good to run right before you, like, let's say, do a deploy to production to make sure everything works. But if something breaks on it, it's much more difficult to track down because you don't know who broke it, when it got broken, and that kind of stuff. So. All right, so let's kill this. All right, so that's all of the stuff about TDD that I'm going to really hit hard on this. Is there any questions there? Does everybody think that they could go write a test at this point? Yeah. I mean, I was shocked by how easy it was when I finally dug into it because I really wanted to do it for like 2 or 3 years and just never did it because I had seen all these blog posts about how horrible it was. And then we went and did it, and it was like not hard at all. So next question: why did we want to do an object-oriented approach to the SPS module? There were sort of 3 reasons. One was because it was relatively I put complicated there. It's supposed to be complex. Sorry, that's not bad. You should never say complicated, right? It was a relatively complex thing that we're trying to come up with that had a lot of different parts that all had to interact.
It actually says complicated.
Yeah, that's because I can't spell. My PM said that she would proofread this for me too, and I should have had her do it. Although this is the first one, right? Has anybody noticed any other spelling things? This is like halfway through the presentation. I've only had one spelling mistake. That's kind of, I've had 2 mistakes. Let's just not look at this slide. So it was a relatively complex system that was going to have a lot of different pieces. And so we really saw the opportunity to break up those pieces into sort of different classes and objects that we were going to do it. The second part about it is that it really needed to be extendable, because what you could condition and what you could get to change would be very different in a year than it was when we wrote it, which is, I guess, now actually. And so if we did the object oriented properly, people would be able to just dump classes that they didn't like and put in new ones that did the kind of conditioning or the kind of reactions that they wanted. The third part was because it was stated in our requirements that we could use 5.3 and we could assume that everybody had 5.3, which gave us lots of nice stuff. That was the one for me. I was kind of excited, right? So that was really freeing, by the way. So if you can get that into one of your contracts, your code's going to be on 5.3, it can really help. There's lots of things that are better in 5.3, like closures, for example, which was really nice for doing our tests. So I'm going to talk about our plugin system. And I'm sure people will get really mad at me because there's only like 80 plugin systems for Drupal, and we made another one. And maybe that was a wrong choice, and you guys should feel free to walk away from this and think that. But the big piece that we wanted to do in our plugin system is that we wanted it, when a plugin got created, we wanted it to be an instantiation of an object. We wanted it to be an object. But we didn't want to do something like they do in tests, where the way you define a new plugin is by making a new class. Because that means everything is a singleton class. And at some point, if we were like every single thing that we do in our module is a singleton class, it just felt wrong, right? Like, that feels like we were not properly doing an object-oriented approach. So the way that we define our plugins, and I think that this is going to go to the right place. Ha, it did. Is a simple hook that you say, hey, this is my plugin. You say what class it uses, and then you say what variables I use to instantiate it. So this let us do things. So for example, for the widget one, there's lots of different widgets. So the widget is basically the part that says, hey, get me a piece of information. So in this case, the date. And we really, really wanted to use field, what are they called? Not the formatters, but the field widgets. But they were like way too tied into the entities and the systems. We tried really hard, actually, and we were like, OK, we can't do that. So, so this one is probably one where people are going to write a new class a lot. Right? We imagine that it's the instance for this one, right, is just the title. So you don't have a lot of functions changing there. But so this one, we expect people to have lots of different classes. Every time they win a new one, you'll build a new form. It'll all be a new class. On the second thing, we have this idea of a condition. So a condition is the thing that says, hey, this is what I want to preview. So in our case, our condition was picking a date and then telling the ERS module, hey, find all the things that would be published on this date. If you're doing one, there's a collections module that comes, an SPS collections module, that basically lets you tag revisions. So you could say, these 5 revisions are for if George Bush wins, and these 5 revisions are for if Al Gore wins. And you could preview the site in those 2 conditions, which is one of the big use cases that people wanted for this, was the idea of like preparing your site for an event that you don't know the outcome for yet, but you know what you would do with the outcome, what the outcome would be. So there's another condition that does that, and what it does is it gives you a list of all of the collections, right? But the condition itself is really just the widget and then what to do with that data. So there's this base class, and actually you don't even see it because it's the default. Each one of these has a default, so the default class is being used here. And it just says, hey, what's the widget that I'm going to use? What's the name of me, so that I can find the right, called an override, to transfer that data into something meaningful. And what's my title? So in this case, people shouldn't, like, they would just be doing this hook and could do a lot of stuff without having to write a new class. So that was kind of the idea that we had behind that, right? But when these things get instantiated, we know how to use them. And we can use stuff like interfaces, which I'm going to talk about next, to guide you in constructing these objects if you need them, and have them fall into place in our system, which is part of that collaboration, writing these interfaces stuff also helped a lot with our collaboration, right? Because we would write an interface and then say, hey, this is what I'm going to actually use. And I would start writing code that's going to use that interface before, I basically write a test class for that implemented that interface. And I would start writing my code that was going to use it while somebody else went off and actually coded building that, that condition or that widget. And to keep that in mind, like the main class that we use is called the manager. It's probably poorly named, but it's the guy that manages everything. And I wrote that entire class just with doing tests. And there was this really scary moment when I was actually going to use it on the site and to see, how bad is it going to, how many weeks is it going to take me to get this to actually do something? It took about 2 hours. So I wrote the whole thing just doing the test and using people's interfaces that they had given me for the kind of stuff that they were going to be doing. And then when they finished their stuff, we turned it on, and there's a little fiddling there because you could tell my spelling is bad, and that does affect code as much as I'd like to say it doesn't. And boom, it worked. So that kind of helped. So this is sort of the big chunk this is how we broke up our different class structures, right? So every one of the different plugins was a different sort of class wing. And then we had this big manager. There's a few other ones, and I don't want to go too much into it because at some point it just, people gloss over when you get too deep into this. But if you went and looked, there's a site state one that keeps track of where we are as we go from page to page and that kind of stuff. So let's kill this guy. Control W. So let's go look at this pretty chart. You guys can all read that, right? So here we go. So yeah, we start off and we have our plugin interface. And then we have a whole bunch of, we have a reaction. So a reaction is the one that actually does the work of changing stuff. And we have an override controller. This is the one that actually says where the data, basically where does reaction get its data as part of an override controller. Whoa, that was not what I wanted to do. And then you see these come off, right? And there's a few different override controllers that are implementing that. These are the two ones that actually do stuff. Which I actually want to talk about a little bit. We'll talk about the reactions in that in a second. But you come up, right, and then there's this is, you would expect to see this, right? So we have actually an abstract plugin that gets used by the widgets and the conditions and these overrides. One thing I will notice, I will point out here is that this one actually, and I'll zoom out 1 second, yeah. So all of these guys you'll see are implementing this interface for the override. But they're also implementing a plugin override because these guys get used as plugins. This aggregated one does not actually get used as a plugin, but it does get used in the system as an override, right? So this is a nice space where it didn't have to implement all the plugin things that talk about who it is as a plugin and that kind of stuff. But it does get used in our system as an override, so it does implement that, which was a nice. We had that used a few different places. Where, yes, go ahead. It is not. What did I use? I should probably put this online somewhere. Yeah. It's just built from the code. I did it, actually, I had somebody who had built this before me and they were on vacation all week last week. So I went and found, it's called PHP doc or something that builds this. It's like you say, go in this directory and build it, and it builds this all out. But yeah, it should be easy enough to put online. So it actually is like a whole API document thing. It's kind of nice. But this pretty chart is part of it. And so actually, I want to go and show you. So this was just the plugins. The big one does get a little bit hairy. So docs. So this is all the documentation that it builds out, which is pretty crazy. But yeah, so it's a bit crazy of a class, right? A big map. The thing that I wanted to show in this one is this guy. So you'll see in our test namespace, we have a test version of all of these classes, which really helped us, to isolate all of our tests for other parts of the system. And almost all of these, what they do is they take as their constructor, what do you want me to return if someone calls this function? What do you want me to do if they call this function? So I can pass things to it, and also what a lot of times what they do is they open up what, if someone passes something to a function, it'll say in a public variable what got passed. So if I'm testing, hey, I should be calling a condition with these parameters, I can call my test parameter and then check my test parameter to make sure that that happened. So that was kind of a nice thing with all of our tests. But I mean, basically everything has a test one. It was kind of there's lots of them. And most of these are really small and really easy to write. So let's go back. So one thing that I wanted to say, which is kind of off topic, but it was just an interesting part that came out of this, is and I was going to explain why. Remember how we had some of the things that were outlined nicely and some of the things that weren't? So the basic way the system works is we have these conditions that pick what we're going to look at, right? And then we have reactions that do something with that information. And we thought we were going to have to write tons of reactions, right? We thought we were going to have to write a view reaction and a reaction for basically any place that somebody tried to use data in Drupal. It turns out we wrote a query alter reaction that finds every query that ever gets executed that lets us alter it and replaces the revision ID with a coalesce SQL statement that says, if I have a new revision ID, use that one instead, otherwise use the old one. So that let us hit like almost everything, right? As long as somebody let us alter their query, we could hit it. But it doesn't actually tell us what we're altering, because it's altering all those things. So we had to go back and write like a views one that says, hey, did you alter this? Let's put a class on it. Did you alter this? And that's why that one didn't have that, because we hadn't write a reaction for that. But we kind of thought that was better, right? It would be better to hit everything that you could, and then go back and have things that add display, things that tell you about it, as opposed to not hitting things as much. So that query alter stuff was really, really fun to write. And it is kind of, I mean, I don't know if it'll be fun to read, but it was really fun to write. So, and it does some nasty stuff with the query alter stuff. Yeah? Yes. Yes. Mm-hmm. So that is needed for SPS to work, and it's because the function that it's patching, if you call it, you can call it with a whole bunch of node IDs and it'll give you all of them. But if you call it with a whole bunch of revisions, it only does the first one basically, which I think is a flaw in the function. And I think that it's going to get there eventually. I don't think anybody's objected to it inherently. The problem is that it has to go through D8 first. And D8, they changed that pretty substantially. So yeah, we had 2 patches to core, and one of them got in, so that was kind of exciting.
Just a little bit of backstory. I know Neil and people maintain SPS prototype now.
Okay.
So we've been using a lot in the demo framework.
Mm-hmm.
And so I've been tracking this up really closely.
Right.
And I'm just like wondering, is that patch is considered no movement?
No movement.
I don't really know how to
To prod people about that? Yeah. I bet I need to go prod people and see if there's something that I can do to make that happen more. But, yeah. So let's kill this guy. Woo. All right. So fighting Drupal. So there's 2 big problems that there's probably more than 2. There's 2 that I'm going to talk to you guys about. The first one is working around hooks. We wanted to have nice alter hooks throughout our system, right? But we wanted to test them. And that can be difficult. So, and what we did is what we were showing you guys earlier was we wrote, oh, that was not the right thing to do there. Sorry. Oh, I forgot to show this too. I could have done this if you guys read fast. Whoa! Isn't that fun? All right. Working around hooks. So here is our pretty Drupal object. So what we did with our Drupal object is we used this object when we needed to call some kind of Drupal function. And what it lets us do is change what that Drupal function is. If we if we would have got them to let us use PHP 5.4, we wouldn't even have to do this, because you can do this in PHP 5.4. You can just change what functions do, which I think that's a great thing. I'm sure other people will disagree. But so in this case, we have this org function, which I really should have said original. I don't know why I abbreviated that. And then we have a replacement one. So the first assert is just a null assert, right? So hey, if you call Drupal with org, it should run org, right? And it does, because that passes. Then we called set on our Drupal object to say, no, if someone calls org, call replacement. And that way, now if I call org, I should get back replacement. So if I want to test that my thing does the right thing, when I want to test what I've told people to do when they define one of my hooks, I change what what's it called, like Drupal implement to call my own function, and then I run my code and I get Drupal implement returns what I told it to implement. So it lets you just sort of step in there and throw your stuff in. The other thing that ran into is, well, sometimes I want to do alters, right? So we'll skip this test because it doesn't really say too much. So I need to pass things by reference. So the other way you can do this is you can call ref with your, which is a big array, basically, of functions. And if you call this one, then it does it by pass it by reference. And the reason why you have to have the syntax is because of some limitations in PHP for how I can pass things by reference. So this was our way to work around that. And so let's show you a place that we use it here. I think this actually is the one I just talked about. For some reason, it doesn't actually go to the right spot. There we go. So here we go. I set module implements. Oh, that's exactly what I said. Man, I should have said something else earlier then. And then I make sure that SPS, I set module implement to be a function that returns SPS test MSR. And then I set module invoke to return this method on here. So it's a big array of stuff that I put off into another method so it wouldn't clog up this code. And then I can do my, so is this the test that I'm doing? Yeah. And then when I do my git plugin info, why am I having a hard time reading this? Sorry. There's my cert, right. Sorry. I was actually hoping that this was somewhere else, so I'm a little bit lost in my own head here. Sorry, give me 1 second. Let's read what I'm testing. Oh, right. So that makes more sense now. All right. So this is a plugin that is defined in this big array that I put down here. I actually called the plugin missing required settings. And shockingly enough, it is missing required settings. So when I assert that this should, if I call this function, right, it should throw this exception. And it does. So, but this is a way that I basically could define what I wanted to test, right? I wanted to test that if you wrote a bad hook, that it would break. And this is how I could do that very easily. So I could sort of jump in. We tried a few other ways of trying to one of the ways that we just use another module, a test module, but we wanted to test one thing at a time, which means we would have had one a module for each one of those. Or we could have had a file that we load the file and it has that one thing in it, But each one of those, though, just sort of ran into problems. Also, module invoke, I think actually this was the bigger kicker. Module invoke goes to the database to find, because all that stuff gets cached. And so bad things happen. So trying to get around trying to go to the database was something like this. And it was pretty easy. there's some worry that like, oh, it's going to be a huge performance hit because you're running all calls, through this. But most of this code doesn't get invoked unless you're actually trying to do the preview, which, I wouldn't recommend opening up the SPS module to your entire user base to preview your sites in an uncached state anyways. So also wouldn't recommend you previewing like 10,000 items. I think you would probably run into performance problems. We actually make a big temp table for our query stuff. So we weren't super concerned about being extra performant because we were expecting this to get used by backend users on 10 to 30 or 10 to 100 items, right? Not.
So I'm still trying to catch up here. Is that what you're doing is replacing module invoke with your own functions? So
Right.
that module, you could go through the hook process and not get to the database.
Right.
Got it.
So I could test, does my call of module invoke, like, am I going to actually break when I tell people I'm going to break, right? Like that's what I'm trying to test here.
Very clever.
Yeah, so it worked out pretty well. So any questions on that one, besides the one we just had? All right. My next one, our next fun thing, Control W, all right, was working around forms. So it turns out that Drupal get form does a lot. It's magic, right? It is probably one of the most magical functions in Drupal. And so you don't really want to make a form without using it, is kind of what we turned out. But it needs a function to get passed to it. And you can't do anything crazy like pass an array with a class and a method. We tried that. It didn't work. You have to pass a function. But we had all of our building our forms were all built into our objects. So they were all like methods. And which one got called was dependent on all these, which one the manager picked and all that kind of junk. So we had to find a way to sort of get around that. And we did that with this. Almost closed everything down again. So here we are. And I'm calling Drupal get form. And I am passing it this form, SPS condition preview form. And I'm passing in the root condition, which is an object. It's a condition object. And then I will get back a lovely form. So if somebody calls the manager and says, hey, get me the preview form, I will get a form that's been through Drupal get form, all that kind of fun stuff. So let's go look at that function. For some reason, like I said, the anchors don't work the first time around. So here we are. Here's our preview form. And we load some CSS. You'll see we actually do some buttons and stuff that we wrap around all of that. Let's see if I remembered what I called it. It's Drupal Camp Austin. Yeah. So like right here, this, if I disable the preview. So we have this button, site preview. Those are all on all the forms, right? So they're kind of on our base form. This piece right here in the middle is where we do fun stuff, where we actually grab that object. Where do we do? Yes, we go fill the build info. We grab our condition, and we ask our condition to get us our form stuff. And the other thing we do is that we store our element in the form state. Where do we do that? Right here. Woohoo! Which means that when we go to validate, which happens down here, we can, we kind of cheat here. We know if we cancel that we just want to clear out stuff. But otherwise, we go and get our condition, and we ask it to validate the form, right? And then if we do the submit, the same idea, right? Where's our submit? We're grabbing that element. The nice thing about this is because it's stuck in the form, it actually contains all the metadata for what things people are checking. So actually, like if you go and you do a submit and it actually generates a new form, which happens a lot. So like up here, I actually where is it? I do this. It goes and does an AJAX call and brings up this form, right? So that's all happening. Drupal get form is helping us do all that fun AJAX stuff and make sure all that happens and me not having to worry about it. But we're iterating it over, and every time this happens, that new information of, oh, hey, this is what we're on is getting stored in that object. And because that object's in the form state, it comes along with us, and all that data comes along with us. So even if I go to another page, that information is staying with us, right? That condition is staying in the form, which is very, very nice for keeping the information about our object in our objects. And that way, when our object's done, it can, it's ready to pass stuff off. So while pretty much this is, you get this drop down and you get all these different ones. It's set up, and this is one of those where we didn't solve the problem because it didn't actually exist yet. But it's set up so you could actually have like an and or an or condition that would let you pick other ones, and this could go on and on, right? It could get pretty deep if you had that problem to solve. It's been a year and nobody's written that yet, so probably nobody actually wants to do that. But part of doing it is the idea is that since it's in that state, that root condition is the one that gets stored. So even if new conditions, it has all these conditions that are part of it. That's all just stored in this form state. So we did have to go off and write those form functions so we could pass a name to Drupal, but it wasn't that hard to actually do all the work in our objects. Let's just see that fun picture of CJ again. That's so much fun. Oh, we are. He was very unhappy that I took that picture of him on Hangout. All right, then that's convenient because that's the end. So, any questions? Yeah.
What's your, if you had to guess, what was your ratio of test code to actual production?
So in the library, which is where most of our code that got tested was, it was basically 1-to-1. And it's worth mentioning, this project came in 3 weeks early and under budget, which is not common on projects that I work on. So I would definitely say that adding tests did not, was, at least by itself, did not, destroy our project. So I think actually it probably made us go much faster with our collaboration.
I was going to ask you, so on the surface it looks like, God, this is a lot of work.
Mm-hmm.
But how did it influence writing your actual functional code? I mean, did it make it a lot simpler? You knew exactly what you had to do, or?
So I would say, yeah, the biggest thing it did was stop us from making bad mistakes early. I think that was probably the biggest thing that helped us with it. We would actually think about how we were going to talk to each other or how our objects were going to talk to each other before we went off and wrote them. But we weren't doing it in this sort of abstract way that often, you'll talk about stuff and you won't actually think about how you're going to do it. So it all sounds real and good, and then you go to do it and it doesn't work. Since we were actually writing code that was supposed to do something, it was kind of the best of both worlds. We weren't wasting time writing all the code that was going to implement it all, but we were writing code that was using it. So you were forced to think about it. I didn't repeat that question, did I, Peter? Sorry. The question was, how did it help writing the tests, for making our code either faster or better to write? So I think that was the overwhelming strongest thing. The second thing was the refactoring. Like the plugin system got rewritten 3 times. And each time was less and less work, right? Because people were using it, the other parts of the system were using it, so we couldn't change any of the outward part of it, but we could totally gut it, and we did it. And like I said, I actually gutted somebody else's code doing that part, so which is a terrifying thing to do normally. So, yeah. And as a side note, so I actually had to do a Ruby project recently. So I wrote this little Ruby library, and I haven't written a lot of Ruby, so I threw it up for code review and expected to get pretty bashed, and I did. And the nice thing about it, though, was because I had written all these tests for it, and some of the things were pretty big things. Like I wasn't writing accessors properly. Like there's a Ruby way of writing accessors, and I didn't do that. So I went and changed all that stuff, and it took me like 10 minutes to change all of the stuff that was needed because the tests were there to make sure I didn't break stuff. I mean, it was really unbelievably fast to refactor, probably like 10% of the code. So, yeah. Right.
I'm wondering how to handle like other people's controls that you're trying to do.
Right. So we ran into this, and this is where we actually started writing some web tests to do some of that stuff. But the other thing that we did, and I'm not sure how much of it is still in there, was just writing. Sometimes the best thing to do is write tests against somebody else's code. Like if you want to use their code in a certain way, write a test against it, and then write tests against your code with that assumption being the case. That was a way to get around a problem of that integration where maybe they're going to change their API and it's going to break your stuff. We had sort of a philosophical discussion about whether, well, we should write a web test that just tests all the way through the system, right? But when you do that and it breaks, you don't know where in the system something's breaking. So if you can still find ways to say, well, I want to test your API and see if it does that. So like the ERS one has those. It has tests against the ERS module. Like if I call this ERS function, is it going to return me this? Kind of things. So I would say that's a good way of doing that. But I mean, if it's an integration test, you can fall back on a web test, right? Like that's not a horrendous thing. You're not expecting that to, you're not going to do TDD on that development part of it. So you're just trying to make sure that it works so that you can test that before you deploy or before you release more code. So yeah. Does that answer it?
Yeah, totally.
Okay. Cool. All right. All right, if anybody has any other questions, feel free to grab me. I'll probably be here for most of the day. Thank you guys very much. Oh, wait. I got to take my picture.
All right.
Phew, man, I would have been in big trouble. Okay, please don't do anything wildly inappropriate that I wouldn't want to show my daughter. And all right, thank you guys very much.